This is math board number 11. First problem says that x squared equals 1/3 and we are to solve for x. And since x is being squared, we want the exponent on the x to be a positive 1, and right now it's a positive 2. So to undo x being squared, what we're going to do is take the square root of it. So we'll take the square root of x squared, but what we do to one side, if I take the square root of this left side, I have to take the square root of the right side. Okay? This square root undoes the squaring. So then I'm left with x equals the square root of 1/3. Well, and this is, I'm just going to explain how to do this, but we haven't gotten to this yet in the course. So this is going to be the square root of 1 over the square root of 3. The square root of 1 is 1. The square root of 3 is the irrational number, so it's going to remain the square root of 3. But by convention, just like we don't leave negative exponents in a problem, we don't leave square roots in the denominator. So what we have to do is called rationalize the denominator. And what that means is I'm going to multiply this by square root of 3, and I'm going to multiply this by the square root of 3. The reason why I'm multiplying by the square root of 3 is because the square root of 3 times the square root of 3 is just equal to 3. And then 1 times the square root of 3 is the square root of 3. So that's the final answer. Number 2, the number of bees in a beehive 1 is this many. The number of bees in beehive 2 is this many. What is the ratio? Ratio is like rational number. It means it can be written as a fraction. What's the ratio of the number of bees in the beehive 2 to the number of bees in beehive 1? So we're going to have beehive 2 over beehive 1, and I have just now written the ratio of beehive 2 to beehive 1. This is the ratio, and then I'm to simplify this. Okay, well here I have the same base, and they are being divided, so I subtract the exponents. So that's going to give me 2 over 5, 10 to the times 10 to the 6 minus 5. So that is going to be equal to 2 times 10 to the first, which is just 10 over 5, which is going to be 20 over 5, or just 4. And so the answer is 4. Mac, what's up?
Okay. Sorry.
That's okay.
Recycling?
Nope, I just got taken out this week for me.
Okay.
All good.
Alright, have a good break. Let's go.
You too. You know what? You're the first student to tell me that.
Oh, well, that makes
And
me
I've
feel
had
good.
3 classes. All right, you have a great break also. Bye. Okay, it says lines K and L below are parallel. So these two are parallel to each other. And then it asks what's the measure of BED. So it's asking for the measure of this angle. There's different ways we can approach it. What I'll do is I'll figure out this angle right here, and I say that this is a straight line, right? And this is going to be 180 degrees. So if I can figure out what this degree is, then I can figure out what this degree is. So it's the same thing over here, is that all together this is 180 degrees. Well, if this is 130 and all together this is 180, this would be 50. Then I also know that the 3 angles of a triangle total 180. So I've got 60 and 50, that's 110. So this third angle must be 70. Okay? And if this third angle is 70 and all of this is 180, well then I have 180 minus 70, which is 110. So 110 degrees is the measure of angle ABE. All right, so there is a postulate that says, this is geometry. We're not in geometry, so hopefully this is a bit of review from last year. That says when you have parallel lines, these two are parallel, just like in the diagram below, or rather above, and we just figured out that this is 70. There's a rule in geometry that says alternate interior angles are the same. So here's an interior angle because it is between the two parallel lines, and this is the alternate interior angle. Okay, also interior, and it's on the other side, so it's the alternate interior angle. So that the postulate says that alternate interior angles between the two parallel lines are the same angle. So if this one is 70, this one is 70 degrees also. Right? We figured out that that was 70. So this is what they're asking for, is what is ABE? Here's what they're asking for. But we already figured this out. So if I extend this, then this is the alternate interior to this. If this is 70, this is 70. Okay, use the Pythagorean theorem to find the distance between points P and Q. So the Pythagorean theorem is a squared plus b squared equals c squared. And the Pythagorean theorem is only used for right triangles. So if I drop a point right here, then I can create a right angle triangle where PQ is the distance but also the hypotenuse of this triangle. So I've got this side, which I'll call A, and this side, which I'll call B, and this side, which is the hypotenuse, which is C. So how long is A? It goes 1, 2, 3, 4, 5, 6. It has a length of 6, so it's going to be 6 squared. And B is 1, 2, 3, 4, 5. So, excuse me. So then I'm going to have 36 plus 25 equals c squared. And I'm going to have 30, 50, 61 equals c squared. And then just like in the first problem, the undoing of the square, right, because we don't know what c is until it has an exponent of positive 1, right? All those times we've said that it needs to have a positive 1 coefficient, it needs to be isolated, which it is, and it needs to have a positive 1 as the exponent. The problem is this has positive 2. So to undo squaring, we take the square root, and if we take the square root of one side, we have to take the square root of the other side. The square root will undo the squaring, and I'll be left with c equals the square root of 61. And if we approximate that, the square root of 61 is approximately 7.8. So I'll say approximately, that little line for approximately.